Okay, so we're going to prove the quotient rule. So we're going to take the derivative of f of x over g of x, and with the limit as h approaches 0, we know that we just have to substitute it to the formula. So f of x plus h over gx, g of x plus h minus f of x over g of x, and everything over h. So we're going to make the denominator the same, right? So I'm going to multiply the left term with g of x over g of x. And the right term, I'm going to multiply it with g of x plus h over g of x plus h. So now denominator will be the same over h. Because this is multiplication, I can put all the denominator from the numerator into the denominator. So now I'm combining it with h. So h times g of x plus h plus times g of x. The order doesn't matter because it's multiplication. And then I'm just going to leave the numerator, f of x plus h times g of x minus f of x times g of x plus h. Alright, just like the product rule, we're going to add what is called special zero. So f of x plus h times g of x plus the special zero minus f of x times g of x plus h over the same denominator. So h times g of x times g of x plus h. Alright, what can we create from this special zero? So we can create minus f of x times g of x plus f of x times g of x. And the reason why we want that to be the blue functions is because we want to factor out the g of x and f of x later in the next step. Alright, so let's factor out g of x for the first and the second term on the numerator. And if I factor g of x, I'm left with f of x plus h minus f of x. And if I factor the last two terms, I factor out the f of x, I'm left, if I factor out the f of x, now instead of factoring out the positive f of x, I'm going to factor out the negative f of x. And the reason why, so then I can simplify the g of x plus h minus g of x, which later will become the derivative of g of x over the same denominator. Alright, now you can see the pattern here. There's an f of x plus h minus f of x, right? So I'm just gonna put the denominator h back to the numerator like this. Same goes with the g of x plus h minus g of x. And the reason why, you know that simplifies to the derivative of g of x and the derivative of f of x. So now on the denominator, I'm left with g of x times g of x plus h. Alright? We're almost there. So limit as h approaches 0, g of x Okay, so let's just rewrite derivatives of f of x over g of x equals Let's simplify denominator. X plus 0 is x, so it's g of x squared, because it's g of x times g of x. And the numerator becomes g of x times derivative of f of x minus f of x times the derivative of g of x. There you go. Don't forget to subscribe.